Hello everyone, and today we are going to start our introduction to our electricity unit. So in this lesson we're just going to focus just on the real basics of electricity, kind of just what it is and different types that it has, before we get into greater detail. So the first thing that we need to know is, what is electricity? So in general, we can define electricity as the interaction of electrical charges or electric charges in atoms. And so this is what causes this kind of change in charges. So that could be positive or negative as they kind of flow in that kind of differential. And so we'll look at how that works. And so in atoms, electrons are the negatively charged part and the protons are positively charged parts. And so I know you have a little bit of that background on there, and so we'll spend a lot more time talking about this later when we get into chemistry and things like that. And the law of electrical charges states that like charges repel and opposite charges attract, right? This is something you've probably heard before, whether it relates to this or not, just like north and south magnets attract to each other and things like that, which we'll actually talk about magnets later on and how they actually do connect to electricity. So we can see in the image on the right that we have the image showing, two positives are going to kind of push apart from each other, two negatives are going to push apart, then of course the two opposites are going to attract. And so that's that idea of charged particles. And that'll come into play for a couple of our different forms of electricity. So let's look at those types. So there's going to be three different types that we look at. That's going to be static electricity, static discharge, so they're similar but a little different, and then there's current electricity. So let's look at that first one. So the first one, static, is the buildup of electric charges on an object. Now, you're no stranger to static electricity. Now, if I just kind of move myself a little bit here out of the way, so that way I'm not covering up one of our images. So if we are there, in this top right image, you can see that we have these little, paper shavings actually attracted to that metal on the pencil. And that's because what's ultimately happening is we have one side that's a lot more positive and one side that's a lot more negative, and so they actually attract. You may have also noticed this in a similar situation below, in which you have a balloon that actually can get to attach to your head. You know that if you take that balloon, you kind of rub it on a fuzzy surface, felt and things like that. What it'll actually do is it does build up a charge, but it kind of gets separate, charges it to have either an overload of negative or positive. In the image below, we have the balloon being negative, and then that's what causes it to stick. This could sometimes also happen if you're ever taking clothes out of the laundry. You may notice some clothes sticking together, especially socks love to do this, right? All of those things. And that's because there's a big opposite in those. Now, as we know, if we have this static buildup, sometimes that'll also lead to something else, and that's going to be our static discharge. Now, our static discharge is a sudden and brief flow of electrons, so it's not sustained, it's a shock, right? Some people just call it, they get shocked. That's exactly what static discharge is. So you see kind of in that image on the very, very top, in which sometimes you'll be able to visibly see that spark. I know a lot sometimes even in the winter, I'll get shocked by my car when I'm getting out of my car. If I'm wearing like a down jacket, they actually can have quite a bit of static sometimes built up, especially if it's really dry, which it can be in the winter. And I would actually have a pretty visible shock. Actually, my garage lights would be out and be kind of dark, and I would get out and I'd reach and you'd actually see it light up a little bit of the garage for that moment. You could physically see that shock. So they can be quite large, right? Some people run around, they'll build up some static and they'll hope to discharge, and they'll go, poke their sibling or their friend and hope to shock them and things like that. Absolutely. The bottom right is just me being funny and saying that, force lightning, if you're a Star Wars fan, would be an example of static discharge, which effectively it would be. Granted, we don't have that, at least that we know of, right? But it still adds a nice little visual for static discharge. So if only we could control that static discharge a little bit more instead of shocking ourselves, right? And the third one is going to be current. This is the one we're going to spend the most time looking at. This is the one that as a society we use the most and we rely on the most. So current is the continuous flow of electric charges. So you'll notice that that's different from that discharge, and that's part of the reason I talk about that. That static discharge is just super quick. It's just a snip of time, where current is continuous until you deliberately turn it off or turn it back on. It won't stop. And there's two actual types of current electricity, and you've likely heard of them before, either because you've just heard of them before and you've looked into electricity, or you've listened to AC/DC, the rock band, right? That'd be another one you may have heard of. That's actually their inspiration of their name, why they have a lightning bolt as part of their symbol. So we have AC and DC. So AC is an electrical charges that flow in one direction and then reverse repeatedly. Now that's the one that's really primarily used by us as people. And then there's DC current. So it's that electrical charges move in one direction. Now DC is something that's going to be provided by batteries. So anything that's battery powered is running on direct current. Anything that's going to be on alternating needs some form of generator in order to create that. And usually there's actually a cycling magnet and things like that in there. And we'll cover some of those things in a lot more detail. So now let me explain some of the images I have here on the screen. So in the upper right hand corner, we have two things, the blue line representing alternating current and the red line representing direct current. And then we have voltage on our vertical axis, and we have, well, let me get a good color here. So we have voltage up here, and then we have the amount of time just kind of going along here. So what does this actually mean? So a direct current, the battery, it continuously is putting out the same voltage. Now realistically, over time, as that battery starts to die, this kind of starts to drop and it's going to be losing that power. Voltage is kind of like the power, you know, for kind of broad strokes. That's effectively what our batteries are, you know, like a 12-volt battery, things like that. It's the amount of power that they can actually give. And then with this alternating current, what's actually happening, so let me just clear off some of my marks here. I think a lot of people find this kind of look confusing because they say, oh, well, this alternating current eventually is not giving any sort of power. And that's actually true. There's a brief moment in time where the power is zero, except these cycles are super fast, really, really fast. That's going back and forth. And so what ends up happening is we have voltage, 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 voltage. It doesn't matter if this looks like it's negative. That doesn't really have an impact. What this is actually kind of showing is if we look on the image below, in which you can see these little yellow orangish circles are representing the current. So we have it kind of going, it goes one way and then it kind of also rapidly goes back the next way. That's basically the cycle. So it's going one direction, it changes direction. It's going one direction, it's changing direction. So that negative, so this kind of positive and this negative kind of piece is more of the direction than it is the value, if that kind of makes sense. So it's rapidly going back and forth. Now, if you notice, a lot of times when you look on electrical things in your house, especially light bulbs, that would be a good one, you'll see it has a label of hertz. And we'll talk about this later, especially when you get to waves. Abbreviated HZ is what it'll have on there. Now that represents the frequency, or how quickly it goes back and forth. And frequently you see like 60 hertz. That's a pretty common one. Something's like 50 hertz and whatever it might be. That means it's going back and forth. So it's doing this kind of back and forth motion here 60 times every second. Okay. And that's what a lot of our lights are actually doing. And this is so fast, this kind of turning bright, turning off, going back to bright, turning off, going so fast, I mean, it does that 60 times a second, we can't even perceive it. But it's also sometimes why we get headaches, because sometimes we can't see it, but we are still kind of reacting to it. And that's where you kind of get some of that eye strain and some of those things. So that's what's kind of interesting. That's also why sometimes a light that's starting to die, it's not as efficient, it can't cycle those as fast, and it'll actually start to flicker before it burns out. So that's another reason that that's happening. So that's kind of what alternating current is, and it's really just this rapid back and forth. We cannot have alternating current with a battery, and so we see an example of DC current on the right and the bottom here, in which you'll see these just constantly going in that same direction. And this is also why a lot of the times when you put batteries into a device, the direction matters, and it's absolutely true, because it can only travel in one way. It can't reverse. And so it has to travel the pathway in a specific order in order to power the needed components of whatever it is, whether it be a flashlight, an Xbox controller, or whatever it might be. And so that's ultimately what's happening in this image here, is what it's kind of showing. And that does end our video on your introduction to electricity. Just kind of, again, getting that brief idea of what's happening, what is electricity, and primarily looking at those AC and DC types of current. If you have questions, absolutely let me know. Have a good one.